Okay, so the first numbers you ever learned when you were, I don't know, 2, 3, 4 years old were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then hopefully you went higher and everybody got more excited. Okay? These are called the natural numbers, sometimes called the counting numbers. Okay? It's the first subset of the numbers that we use today. Okay? All right, now you rolled into kindergarten, and what did you learn once you got to kindergarten? Yeah, 0. You learned the number 0 and what it meant to be 0, yes? So, 0, 1, 2, 3, 4, 5, etc. These are called the whole numbers. So the only difference between the natural numbers and the whole numbers, the only difference between the natural and the whole numbers is 0. Okay? So by adding 0, we set a whole new subset of numbers. All right. Okay. So then, what did you learn after you learned 0, 1, 2, 3, 4, 5, all the way up to 100? What did you learn next? Yeah, you guys you can be loud. I'm loud. Yep, negative numbers. So remember, you got out that big strip and it had 0 in the middle and there were negative numbers and positive numbers, and we learned our negative numbers. -4, -3, -2, -1, 0, 1, 2, 3, 4, and they go in both directions. That was the next set of numbers that we learned. Okay? These are called integers. Integers are positive and negative whole numbers. Sweet. So we just keep adding to our subsets. So now you got into like second or third grade, and what did you learn next? Oh, you're a loud bunch, aren't you? What'd you learn after you learned the negative numbers? Yeah, decimals and fractions. So any number that can be written as a fraction these are called rational. Rational numbers. Now, here's key, ladies and gentlemen. Look, ratio. You guys know what a ratio is, yes? Right, it's a comparison of two numbers. It's a fraction. So anytime you can write something as a fraction, it is a ratio, hence rational. Okay, so what happens if you have a number that you can't write as a fraction? Look at you! Very nice. It's irrational. Cannot be written as a fraction. Okay, what number can't be written as a fraction? All right, I tell you what.
0. It's 0.
0 can be written as a fraction. 0 divided by 5 is 0. Therefore, it is a whole number, which is an integer, which is also rational. Good answer. Thank you for trying. What else? All right, let me ask you this. Do you guys know what a perfect square is? A number that is a perfect square. Okay, you have 60 seconds to figure it out. Look it up in your phone, talk to each other, ask your mom and dad, ask your big brother or sister, whatever. You have 60 seconds to, in the chat, put in, for me, a number that is a perfect square. So I'm looking for a number that is a perfect square. Everybody got it? Go. You got 60 seconds. Do 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 do. Ba do 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 do. How many have I got? 1, 2. I got 12. Yeah, don't use anybody else's. Ella put up 9. Find a perfect square. Try not to use someone else's. Ooh, this is going to be hard. Oh! Look at you all. Oh my gosh, I'm so proud of you. So, a perfect square, bonus knowledge here. A perfect square is any whole number multiplied by itself. So all you have to do is pick one of these numbers, multiply by itself. The result, perfect square. Okay? So, perfect squares that I know. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. How's that? Those are all perfect squares. Richards? What's the square root of 81? Type it in. Let's see what you get. Yeah, now. Sweet. Okay, next one. Next one you don't have to type in. You just have to hold it up with your fingers. You ready? Square root of 36. Ready? Go. Yeah, 6. Perfect. Okay, next one. What is the square root of 42? Yeah, it's a little more than 6, but it's less than 7, yes? Everybody okay with that? Just give me a head nod, because I can see you. Okay, so anytime you take the square root of a number and you don't get a whole number, it's irrational. The square root of 42 is irrational. The square root of any non-perfect square, irrational. Are we good? And that's all the subsets. Those are all the subsets of the real number system. All of these subsets belong to the real number system. Okay? Here we go. If you next page, go on, let's flip to the next page. This is what it looks like, the real number system. This is what it looks like as a picture. You can see the whole big rectangle is the real number system. We have the irrationals over here and the rationals over here. Irrational numbers cannot be rational. So every number either is rational or irrational. But the natural numbers are within the whole numbers. So if I put the number, I don't know, let's put a number in. Let's put the number 15. 15 is a natural number, but it also is in the circle that contains the whole numbers. So 15 is a natural number, it's a whole number, it's in the circle of integers, so it's an integer, and it's also rational. Most specifically, it's natural though. Make sense? All right, here's what's going to happen now. I'm going to try it so we can have some fun. I'm going to put you guys in groups. Okay? I'm going to put you in groups, and you guys have to take all these numbers down the left-hand side and put them into their proper place. Okay? So here we go. Breakout rooms. Bum, ba, ba. Let's go to 4 rooms. Create breakout rooms. Okay, ready? Go. Open them. There you go. Go to your rooms, figure them out. I'll see you guys in a little bit. How we doing?
Good.
Are you guys talking to each other? You can. See you in a bit. Yeah, now. Everybody coming back.
Oh.
Can you guys see my screen?
Right.
Say that again.
The 2.35.
Oh yeah, 2.35, good question. 2.35 is actually 2 and 35 100ths. Okay, so if you wanted to, you could actually write it 235 over 100 before you simplified it. So yes, if you have a decimal that doesn't go on forever, as we say it's finite, if it's finite, then you can write it as a fraction anyway. Very easily. It's not like the one that goes on forever. Make sense? All right. Hey guys, that's it. That's all I got for today. No homework for tonight. We'll finish this section tomorrow. We'll do a whole bunch of examples and whatever and finish learning it. So, that's all I got today. Good to go?
Yep.
Perfect. Hey, good to see you all. We'll see you tomorrow. Bye.
Bye, all.
Does anybody have any questions on the subsets of the real number system? Okay, here's what I'm going to do. I am going to put you guys into your own little classroom, your own little rooms, and on the very next page above the homework, there are some questions. I want you guys to go through the questions and answer them. The true or false questions, if one of the answers is false, here, let me go here. Oh, hold on. If you look at the circles here, you can see that the whole numbers are inside the rationals. All the whole numbers fall entirely within the rationals. So from here you go. On this page here, there's, 7 true or false questions and a couple questions at the bottom. If any one of those questions is false, change it so that, tell me why it's false or what you could do to make it true. Everybody good? All right, perfect. I'm going to put you into breakout rooms. Okay, I'm going to put you in breakout rooms. You guys can answer the questions, work together, talk to each other, etc., etc. See ya! Okay, here's how we'll play, okay? If you don't know the answer, you can call on anybody else in the class, Caden.
Les.
I love it. Les, why is this false?
Hold on. Give me a sec.
This is good. So you all better have answers.
I know why.
All right, tell me why.
Don't into negative.
There you go. Whole numbers don't include the negative numbers, ladies and gentlemen. There's a good answer. Integers are negative. Whole numbers are not. Very good. Let's move on to number 2. Natural numbers and whole numbers include the same set of numbers except whole numbers include 0. Please type in your answer, but don't type enter. All right, go. Enter. Very nice. Yes, ladies and gentlemen, the answer is true. The only difference between Natural numbers and whole numbers is the number 0. Great. Next column, number 1. True or false? All rational numbers are real. Go ahead, type in T or F. Go. Enter. That is in fact true, ladies and gentlemen. Every subset that we're dealing with are real numbers. Very nice. Number 2. All whole numbers are rational. All whole numbers are rational. Ready? Return. That is absolutely correct, ladies and gentlemen. And let me show you something real quick. A picture standpoint, you can see that that is in fact true. Ladies and gentlemen, number 3, all rational numbers are natural. Enter. That is emphatically false. Thank you very much. Who we got? Abby. Speak to me. Why not?
Natural numbers are like whole numbers, and irrational are like decimals and fractions.
Sweet. I'm going to tell you this. Hold on one second. Here's what I want you to do. Just give me a counterexample. In order to disprove anything, all you have to do is give one counterexample to someone's statement. This is a good thing for you guys to know. So give me one counterexample. Does that make sense? Go ahead.
Natural numbers are like 1, 2, 3.
No. Just give me a rational number that's not a natural number. Uh-oh. You froze up, I think. Give me any rational number that's not natural. 0. 0 is a rational number. It's not natural. There you go. 2.6. 3/5. Any fraction that can only be written as a fraction or a decimal would not be natural. There you go. Number 4, all whole numbers are natural. True or false? Enter. Great. Viesa, counterexample.
0.
Bingo! There's the only one, ladies and gentlemen. There's your counterexample. 0 is a whole number that's not natural, so all of them are not. Thank you very much. Number 5, last one. All irrational numbers are rational. True or false? Enter. Yeah. Ladies and gentlemen, irrational and rational are opposites of each other. It's impossible for them to be both. Very good. Okay, here we go. This is the understanding of why we need to know the number sets. You have 16 marbles and you want to divide it evenly amongst 5 kids. How many does each child get? Enter your answer. Enter. Let's see what you get. Well, hello there. How are you? Great. Thank you for stopping in. Okay. The answer is you can't do it. Right? I mean, you want to say the answer is 3.2, but you can't have 3.2. You can't have 3.2 marbles. So, if I asked you this question, your answer would be in the set of whole numbers. You can't answer this question in the set of rational numbers because you can't have 0.2 marbles. Does that make sense to you all? Yeah? Okay. Sweet. Okay, the next question, same type of question. $16 divided evenly amongst 5 children. How much does each child get? Enter. There you go. Yes. Ladies and gentlemen, the answer is emphatically $3.20. This one you can answer. And you can answer correctly and exactly because the answer to this one is in the set of rational numbers. Your answer doesn't have to be a whole number because we can have parts of a dollar. Makes sense? Perfect. All right, so. Okay, so what we got here, that's it. That's what I got for you guys. Now, here's what's going to happen.